experience with others who are interested in learning about blockchain technology and smart contract development. Just a second, let me share the presentation. I hope you can see my screen where I'm sharing the presentation. I'm not sure if you're all seeing it. Femi, is the screen visible where I'm sharing the presentation? Okay, so the main focus of this workshop, like we are going to be exploring the how to develop secure smart contracts with OpenZeppelin. So like you're just going to see how we are going to use OpenZeppelin to develop the safe smart contracts, which are like not easy to hack and tamper with. So the main contents of this presentation or this workshop today, we are mainly going to discuss blockchain and smart contracts, blockchain security vulnerabilities, the OpenZeppelin framework, and writing secure smart contracts on OpenZeppelin. So generally, the blockchain technology has potential to revolutionize various industries, including finance, supply chain management, and healthcare. However, it is important that the technology it is still in its early stages, and there are various challenges that need to be addressed. One of these challenges is the security of smart contracts, which are so like we've just been talking about smart contracts, but we haven't expounded on what they are and why the main issue of security has to be focused on. So generally, a smart contract is a computer program that is deployed on the blockchain. And the code of that contract is typically written in a programming language specifically designed for the platform or blockchain, such as Solidity for Ethereum. So once deployed on the blockchain, the smart contract becomes a permanent part of the blockchain's history and executes its predefined functions according to the rules and conditions specified within the code. So however, we should note that these smart contracts are vulnerable to attacks and hacks if not developed properly. So that is why I'm excited to be facilitating this workshop on developing secure smart contracts using OpenZeppelin, and we'll see how which attacks these are that we are talking about and how to mitigate them. So I've just been mentioning OpenZeppelin, but I haven't gone further into introducing what it is. We've seen the industries that blockchain is going to revolutionize and the impact that it has, like it's going to have in the day-to-day life, because it's also going to impact finances and all that. So we have to look into which are the best ways that we can keep these systems or platforms safe. So OpenZeppelin, let's delve into what it is. It is a powerful open source framework that simplifies the process of developing secure smart contracts. OpenZeppelin has gained significant recognition and adoption within the blockchain community due to its robustness and focus on security. Then at its core, OpenZeppelin has a list of like a number of pre-audited libraries all in one. Like these libraries have been checked and confirmed that they are free from hacks and attacks, such that when you use them and integrate them into your systems or your blockchain application, you're providing a proof that the systems are going to be safe from attacks. So let's look at the features of OpenZeppelin. I've previously mentioned that OpenZeppelin has pre-audited libraries. So these libraries have been tested over time and time to ensure that they're safe from attacks. And then OpenZeppelin also has standardized protocols. So previously, before these standardized protocols, like everyone had their own way of developing either fungible or non-fungible tokens, the non-fungible tokens, the NFTs. So there was a standard that was developed such that there's going to be a specific format on how to develop, let's say, an ERC20 or an NFT token. OpenZeppelin also came up with libraries such that you write the contracts in a specific format such that your token contract for, let's say, a specific coin, an ERC20, doesn't look much of a difference like with other coins. Like the code is just similar when you look at them. Even the NFT codes of various NFTs, most of it is usually similar. So this standardized protocols are provided by protocols like OpenZeppelin. And then I can also say that these libraries encapsulate the best practices and secure design patterns for building various types of smart contracts. Instead of reinventing the wheel all the time, like writing these tokens. And then I can talk about modularity. There are various modules of development in when you're using the OpenZeppelin library. So it can make contract development easy. And then it also offers a feature of upgradability. OpenZeppelin offers libraries that can enable you to upgrade your smart contract once it's already deployed on the mainnet. With smart contracts or the blockchain applications, it's not easy for you to make bug fixes, since we are trying, like with the blockchain technology, one of the principles of it is trying to make the systems immutable and tamper-free. So once it's deployed, it's not easy for you to make changes. So when you're using OpenZeppelin, there's some libraries that help you with adding new features and fixes on an already deployed contract that is already on the main chain. Okay, let's explore some of the common vulnerabilities in smart contracts, since we are looking at OpenZeppelin and how to counter some of these vulnerabilities. So before we dive deeper into the practical aspects of writing secure smart contracts with OpenZeppelin, let's identify these vulnerabilities, which are crucial to ensuring that the security and integrity of your contracts are maintained. So fortunately, OpenZeppelin provides solutions and best practices to mitigate these risks effectively. So one of the common risks or attack that usually happens in smart contracts is the reentrancy attack. A reentrancy attack is a vulnerability where an external contract can exploit the order of operations in your contract to manipulate or drain its funds. OpenZeppelin addresses this by using the checks, effects, interactions pattern, where external calls are made after all state changes are completed, reducing the risk of reentrancy attacks. And then another type of attack that usually takes place in smart contracts is the access control attack. So in this, unauthorized access to certain functions or data within a smart contract can have severe consequences. OpenZeppelin offers an access control module that allows you to define roles and permissions. So this ensures that only authorized users can perform specific actions. This helps to mitigate the risk of unauthorized access. So there are many risks, but here I just decided to highlight the three most common ones. We're going to provide resources on where you can read about these smart contract attacks and vulnerabilities. So right now I'm just highlighting three and then going to delve deeper into one of them and how to mitigate it using OpenZeppelin. So the other attack or vulnerability that takes place in smart contracts is the front-running attack. So front-running occurs when an attacker observes pending transactions and exploits the knowledge of the upcoming transactions for their advantage. So OpenZeppelin contracts include various functions to mitigate the risk associated with front-running attacks, such as using nonces and secure ordering of operations. So by leveraging OpenZeppelin libraries and following the best practices, you can significantly enhance the security of your smart contracts. OpenZeppelin has also gone through rigorous audits and is widely adopted, which adds an extra layer of confidence to your development process. So through this workshop, we will demonstrate how OpenZeppelin helps mitigate these vulnerabilities. We are also going to explore code examples and practical exercises on how to incorporate the appropriate OpenZeppelin modules and best practices to ensure the secure development of our smart contracts. Okay, let's move on. So, now that we have an understanding of common vulnerabilities and how OpenZeppelin can mitigate them, let's proceed to this sort of hands-on exercise. I'll just go through this code and you're going to open Remix. I'm not sure if there's a link that has been shared with you on how to get to Remix. And then you're going to try to test this piece of code as I explain what it does. Just give me a few seconds as I try to load OpenZeppelin, as I try to load Remix, sorry. Can you see my screen where I'm sharing the Remix tab? Awesome. So when you head to Remix, you create, I think everyone's looks like this. So you come here and create also files and the extension of your tool. Let me just copy and paste these lines of code here. Okay. So once you head to Remix, I think you've read about or you've been introduced on the structure of Solidity, let's call it contracts or Solidity programs, and seeing how they're arranged or how they're written. So basically, nice. So basically, what this code or like this piece of contract or code does, it shows how access control can be maintained in Solidity or blockchain-based applications, and how OpenZeppelin helps in controlling access of certain functions or certain programs in the blockchain. So let's say, for example, if you had a bank vault and only few people are required to have access to it. So you just give it restrictions, like when you're writing that type of system or code regarding that bank vault, you have to give different like roles or like being an admin to certain functions, or give it different views such that this person who is in this department or this so section would not have access to see how many people have banked with us, or how much funds in total are in the bank. Or yeah, like it's all about transparency and providing roles and providing security to different whole contract. So this code mainly, so this access control contract, like first line is an identifier. Like every Solidity program has to start with this license identifier. So it just has to come in something like comment. And then every Solidity program has to start with the keyword pragma and the Solidity version. So this version tells it gives us the version that program is going to plot on. Like the let changes every time now and then. So when you use each program is going to be or the latest bug. So if I decided to use let's say 05, it's going to cause like a security issue such that it's an old, not really a deprecated version, but a very old version that doesn't have the latest bug fixes for the Ethereum virtual machine. So another thing I'm going to tell you about. So if you want to write an access control contract, you have to inherit the OpenZeppelin library, which is called the access honorable library. As you can see here, it ends with the .sol extension. So if you're using an IDE, let's say like Visual Studio Code, you'll have to download the packages for OpenZeppelin. But when you're using what is it called? When you're using Remix, it's a bit easier. So you just go to the OpenZeppelin GitHub, and then you search for contracts and the look for the ownable contracts and copy the URI. Then you just write import, and then you just import the URI here. So it's going to import all the libraries from the access control contract. As you can see here, like all the utilities and libraries are going to be imported directly here. So this contract access control, like you just write contracts like the way you write other programming languages, which start with something like classes, and then inside the classes you have functions. So with Solidity, the class represents something like the contract represents something like class in the object-oriented programming languages. So this access control contract, it inherits the OpenZeppelin honorable contract. The contract has a white list of addresses that are allowed to access a restricted function called restrict function. Initially, only the contract owner has access to this function. So in this function, only the owner that has been given access will be able to access this restricted function. So this is the main aim of writing the whole of this code. So there's a specific function, only a person with a specific address will be able to gain access to this restricted function, as I'd given you the example of, for example, a bank vault. So here, after writing the contract and inheriting the ownable library from OpenZeppelin to show that this contract is going to have an access control type of mitigation like a mitigation to the access control attack. So, and then we're also going to have a mapping. A mapping is basically a data structure in Solidity. So like it's a key value data structure, which shows a key, let's say an object and its value. So here we have a mapping of, which is called whitelist, and it's in the view of private, like not any external contract can access it. You see how powerful Solidity is, like in maintaining the variables and its data structures. So this mapping maps each address, like each whitelisted address, to a Boolean value. So a Boolean value is basically either a true or false. So it should return something like, if this address is whitelisted, it should return true. If the address is blacklisted, it should return false. So each address is mapped or linked to a Boolean value. So we have a function here to add a whitelist address. So these are the parameters, like the address that we need to add for it to be whitelisted, and it is public, meaning that it can be accessed by any function inside this contract. Like any function can call this function whitelist because it is public. And we're also inheriting the only owner modifier. A modifier is basically like a function. So you see, only owner modifier. So this only owner modifier is inherited from the OpenZeppelin access control libraries. So it shows that only the owner can add a whitelist. So if the owner adds a whitelist address, it's going to automatically be registered as true. Like here, the Boolean is going to be true. And then we also have a function to remove whitelist. So a whitelist is also like, to remove anything to do with a whitelist is an account address. So it's of the value of address, like address is the data type, and it represents the account that is to be whitelisted or removed from the whitelist addresses. And the only person who can do this, like remove the whitelist, is the owner, like the person who has deployed this contract. I'm going to show you just in a minute. I'm just trying to make you understand these functions. And then once this person, like this address has been removed from the whitelist, so the whitelist account would be automatically set to false. So this is how powerful smart contracts are. And then we also have a function to set, to check who can access these restricted functions, or who can access the whitelisted addresses. So here, this is just a check that you're going to do. And the only person, like anyone can do this check, and the value that is going to be returned is also going to be a Boolean, like the bool. So once we check on which address can access the restricted account, it's it's going to give us, let's say if we've input that address, it's going to give us an input whether that address is already whitelisted to check or not. So it's going to return a Boolean. And then we also have the last function, which is like our main function here, which is the restricted function. So the restricted function, the thing that it does is it doesn't modify anything, but it's just like it performs the restricted actions that this smart contract is to do. And these restricted actions can only be done by the address that has been whitelisted or the contract owner. So let's try to run this smart contract and see how it goes. So it's already running. We've compiled it. Let's deploy. So before I go on to deploying, we have a number of addresses here, or a number of accounts. So these are the test accounts that you're going to use during deployment, and the ones that you're going to choose, like one of them to whitelist. Yeah, so we have a number of them. So I've chosen the first one, that is going to be the deployer, or we also call it the owner of this contract at the moment. So the deployer becomes the automatic owner of this contract. So let me just click on deploy. The contract is deployed successfully. Let's look at it. So these are the functions that we wrote here for our access control contract. So we have the function to add a whitelist, this one, and then we have a function to remove a whitelist, which is this, and then we also have an automatic function to renounce ownership. Let's say if me, who is the contract deployer, wants to renounce my ownership, I have to transfer ownership to someone else, and then I can click on renounce ownership and give it to that person to have full access to it. And then this is used to check on which a specific address that I have given a mandate to access, if it is able to access that restricted function. And when I click on owner, it can also show me the owner of the contract, who is the deployer, and then this is the restricted function code. So let's just give it a try and test this out. As I had shown you earlier, this is the contract that I had deployed with. So this is the owner of the contract. Let's just test it. When you click on owner, it gives you the exact contract that's deployed that specific, it gives you the exact address that deployed that specific contract. So this is the only owner that you're talking about. When you see the only owner, this address is the only owner that is existing at the moment. So we want to add a whitelist address and give it authority. We choose one of these addresses here. So I'll go with this, then I copy it. But before I proceed, I have to change to the same address that I used to deploy the contract. Okay, then I take this address and paste it here, and then I add to whitelist. Yeah, so you can see this, the transaction has gone successfully with no error. So if I want to check who can access, who can access this restricted function, I can copy the same address that I gave whitelist authority to, and then it's going to give me a result if this address is able to access it or is unable to access the restricted function. Let me just try to copy it again. So this is the address that we've whitelisted. Let's see if you're now able to access that restricted function. Yeah, you see the result has come here as true. So this means that the address is now able to see the restricted functions. Let's say like the example that I've given of the bank vault. So you can work with such a contract in this way. You have specific functions that you only need to be viewed with a specific department or specific addresses. So you just write a function similar to this. So you see, like, this one gives you all the details on who is able to see what and who is not able to see whatever. Yeah. And then, for example, I wanted to see if since at the moment I am the one who, the only owner is this person who deployed the contract. If I try to run this restricted function, I'll get an error that this, let me try to, yeah, that this transaction was reverted because access was denied. So like, if I try to change the deployer, this is what it gives me. It gives me the reason that the contract, like the transaction can't go through because access is denied. Like, it has to be the person who has been given access who can be able to see the restricted function. So whenever I run this, it will tell me that the access to this function is denied. So I can also add a number of functions to the whitelist, and I can remove a specific function to the whitelist. Let me just try again. Let me go back to the, so we have this. This is the contract that this is the address we had added to the whitelist. We can try to remove it and see if it can now see the restricted function. Yeah, so we are able to remove it. So let's just try to check again if this address, like this specific address, now has access to that specific restricted function. So you see, it's now registering it as false, like it doesn't have access to it. You can also see access controlled contract cannot, like doesn't. Yeah, you see, it's returning false, that this address can now not see the restricted function. So basically, this is how access control is supported by the OpenZeppelin libraries. So like the restricted function can only be called by the addresses that are present in the whitelist. So if the caller doesn't have access, the function reverts to access denied, as you have seen here from the previous example. So by using the OpenZeppelin ownable contract and its access control mechanism, we can effectively mitigate the problem of access control in the contract like we have seen above there. The contract owner can manage and whitelist and granting and revoking access to specific addresses. Okay, so I'm going to share with you the code, and you can also try it. Like you can, let me stop sharing. You can also try it on your remix, like on your end, and you see how it goes. Like just play around with the code and the addresses. Yeah. So if anyone has a question, please, this is the time. Does anyone have a question? I will share the code on Telegram. Okay, I'll also share the GitHub link very soon when I'm done. Okay, turn on the video. Thank you so much. Thank you all for tuning in, and I want to thank the Code 247 team for organizing this amazing event. It was really wonderful, like facilitating the workshop and sharing my knowledge about the blockchain technology. And I hope to learn from you guys too. What tool can we use to code the blockchain? You can use Remix. Let me try to share the link. You can use Remix, you can use Visual Studio Code. Those are the best that you can use to write blockchain code or Solidity code. Anything else? Oh, thank you so much for tuning in.
Yeah, hello.
Just come.
Yeah, hello, Fatma. Can you hear me?
Yes, she's
Yeah,
here.
I can hear
Okay,
you.
awesome. That was an excellent presentation. Like a whole
You
lot
come,
of things now. Like we've learned a whole lot of things. So, like from the hub here, I believe, like, is there any question to ask? Do we have any question?
Well, I wanted to ask if.
Come up. So, Fatma, we have one of the participants with a question.
So I wanted to ask if you can use the OpenZeppelin as a plugin, whether you can actually access it as a plugin in Visual Studio Code.
Okay. Yeah. Fatma, did you get that question?
No, it wasn't clear. Pardon, come up again.
Good. Let her repeat herself.
Hello, Fatma.
Yeah. Can you hear me?
Can you hear me?
Yeah, I can hear you
Okay.
clearly.
So, like, can you just repeat? Did you get the question first thing first?
No, I
Were
didn't
you able
hear.
to get the question?
She's talking about.
No, it wasn't clear. Please repeat. Is the question in the chat? Because I can't hear what's being asked.
Hello.
Hello, Fatma.
Yes.
So can you hear me, Fatma?
Yeah, I can hear you.
Okay, so yeah, thanks so much for that presentation, Fatma. That was awesome. Thanks so much. So now we are moving on to the next. So the next section, which has to do with the next section is cyber security for blockchain and artificial intelligence. And this is taken by Precious Colin. So the cyber security expert who has series of certification from cyber security and yeah, done some couples of projects with companies who are doing applications within the country. So by Mr. Precious, you can help us for your presentation. Can we put our hands together?